Okay, it's 3:30, so I think we'll start. So welcome all to this Shiny Demo 2 on mobility and spatial. I'm really happy to be here. I'll be the chair of the session. My name is Andrea Cappozzo. I work as a postdoctoral researcher at University of Milan Bicocca. And today we will have 5 speakers. They're going to talk about their Shiny app related to the mobility and each speaker will have 5 minutes, and then they will have further 10 minutes to in private lounges to further explain their contribution related to this field and to showcase their Shiny app. I would like already to ask Agostino to come on stage while I'm gonna explain how this is gonna take place. So Agostino, hi Agostino, welcome.
Everyone, hi Andrea, thank you.
Very good, very good. If you want to set up your slides, in the meantime, I will briefly explain to you and to the other speakers how I will manage this session. So basically, as I said, everybody has 5 minutes, and after 4 minutes and 30 seconds, you will hear a ring from my microphone. That means that you need to wrap up and close your presentation. I think that's all on my side. If you want to start sharing your screen, I think we are all good to start. And I will, in the meantime, switch off my camera, and thank you. Well, first of all, sorry, I forgot to say that Agostino is a PhD student at Politecnico di Milano, and he's gonna talk about visualizing and modeling bike-sharing mobility usage in the city of Milan. Thank you, Agostino.
Exactly. Thank you, Andrea. Today I'm going to show you my app for the visualization and the prediction of bike sharing mobility flows. So right now you should see my screen. And I suppose that all of you that are hearing at least once in a life have used the sharing mobility service. And it's not hard to believe that sometimes maybe you have some problem with the services. Maybe you weren't able to find a bike because the bike station was empty, or maybe you were looking for a car or a scooter, but your app told you you have to walk really a lot to find an available one. So to solve this problem, what we propose, what we offer is a data-driven self-learning forecasting Shiny platform. And the idea is simple, is to use the historical data of the service together with complementary information like the day of the week, the hour of the day, the fact that it's raining, the fact that there is a special event like a football match, and so on. And then to apply novel tools from machine learning in order to predict what is going to happen in the future. And right now, I'm not going into detail in the methodology.
Sorry,
later, if you are interested,
you can to turn off your camera so that we can see only the slides for the recording. Thanks.
Okay, sorry, my fault. Maybe. Yeah, I think that if you double click on the screen, you should see them without problem, but thank you. Okay, so let's see an example of application. We developed an app on a specific case study on BikeMe, the main bike sharing system in the city of Milan. This is a fixed station service, meaning that there are different bike stations located throughout the city where you can pick up or drop off a bike. And what we did was to put together the closer station into the districts on the city and to focus on these districts. And we tried to develop a way of predicting the pickup, drop-off, and bike flows among these districts. And this is the app that we developed. It is available online. So let's see if it is working. Okay. So on the left, under scenario analysis, you can choose what we want to observe and what we want to predict. We can choose the picking up district. For example, we can select Magenta San Vittore, that is the district where is Cadorna, one of the main train stations in Milan. And we can select the dropping off district if we select all, we look at all the pickup from this district. And here on the center, you see the chosen district highlighted on the map. And on the top right, we see the historical data in black and the prediction in orange. And right now, we are trying to predict a Monday. And what you observe is that in the morning, around 8 a.m., there will be about 200 bikes per hour starting from this district. And of course, we can select another day. For example, if we select a Saturday, this is what it happens. And as you can see, the prediction goes down because from this district during weekend, the number of bikes is very low. We can put again Monday and we can play with weather condition. We can play with the temperature here in red or with the rain here. We can put a little bit of rain, for example, in the morning. And you should see this blue curve showing the rain on the bottom, and on the top right, you see that the prediction goes down. And as the rain increases, as you can expect, the prediction decreases until 0, so no bike trips. And of course, we can look at other paths. We can look at the bikes from Magenta to Duomo. This is pretty similar, or we can look at the bikes from Brera to Duomo, and we can look at whatever we want. To conclude, on the bottom right, there is another panel. Okay, 30 seconds left, thank you. And this panel show you how the different mobility drivers, like the weekend effect, the rain, or the temperature, impact on the prediction. And if you're interested, later you can ask it to me. And this was all. Thank you for your attention. This is the team I worked on this project. And this was all. Thank you for listening, and I hope to see you later. I suppose I finished a few seconds earlier, but maybe better like this.
Perfect. Thank you very, very much, Agostino. It was really interesting. Actually, I invite you all to join the private session afterwards if you have more questions regarding the app and that you would like to ask Agostino. Thank you very much. I would like to ask you to leave the stage now, and we welcome our second speaker of this Shiny session is Angel Udias. Angel, I kindly ask you to come on stage.
Hello, everybody.
Good afternoon, Angel. It's a pleasure to have you here. So Angel is a researcher at European Commission Joint Research Center at ESPRES, Italy. And today he's going to talk about ESPRES, a Shiny web tool to support river basin management planning in European watersheds. The floor is yours, and remember I will switch off my camera now, and I invite you to do the very same as soon as your screen is ready to be shared. Thank you very much.
Thank you very much. Hello, everybody. I'm sharing. This. I'm going directly to the application. I'm going my name is Angel Udias. I'm going to share you the ESPRES application. That is a development that we did in the jersey of the European Commission in order to show the general public and some specific stakeholder what is the status of the rivers, in European rivers, and what is are the best management practice in order to improve this quality. After choose the river, the user can also select. There are two modules, one related with the quantity problems and the quality problems. With this demo, I choose the Adige, it's a river basin in Italy, and also the quantity. The quality is really similar, but more related with nutrients and other contaminants. In this case, the first of all that we try to show is the current condition of the river. Now, in order to make understandable what is the situation, what is the pressure that they are under this catchment. No? Water availability with different plots, different maps that show what is the status. There are some political the status by political regions, also with the profile of the catchment. There are also other graphs, as well. There are also the subcatchment, that's the most detailed status. Also, this is water availability. To know the status is very interesting to know what is the water pressure that we can that are in this catchment, and then after a few clicks they appear. There are 5 pressure in this case: is the domestic, the energy, the industry, the irrigation, and the livestock demand. All that we can see in this case that the domestic is the most important demand in this catchment. All these maps are different options. The configuration I don't have time to show all them. And also to finalize with the current status, the user can go to the water exploitation index. That is some sort of relation between the water availability and the water demands. No, water exploitation index higher than 1 means that there's a lot of demands, but a few more than demands than water. Okay, and then once we have an idea of what is the status, we can go to the management practices with the optimization part. In this, the user can configure some parameters. It is related with what is the maximum pressure reduction that can be applied in one sector or in one region. Also can go modify and so the sensitivity is a pre-run optimization analyze that what are the more sensitive regions or sectors where applying a reduction could be more or less effective. And finally, and very important, is that the user can configure how much difficult or how much costly is to reduce the demand in one sector than in other, or in one region in regarding other region. This is an important configuration parameter. And then once the user has set up all these parameters, can launch the optimization process. That is, once he can select the kind of metric to assess the quality and the number of strategies that the optimizer analyze. And then the Pareto frontier arrives, giving one idea about how much are the pressure effort and how much is the water exploitation index, and also each strategy, that is each point, how the distribution of reduction of pressure between sections. Once arrived at this point, it is interesting to compare 2 different strategies of reduction of pressure to analyze if they are of what are the distribution of that and other graphics that then the user can examine what is the effect and the effort applying in all of them. For example, in this case, a graph that there was not in the previous part, but is this Sankey graph where the user, for example, can view graphically how much is the reduction for each one of the strategies in comparison with the demands by sector or by region, and of course go to the same math that before, but we can go directly to the water exploitation index, comparing both strategies. What are higher is negative because I choose a less important than the first strategy, but what are the water exploitation reduction at the end. This is available for everybody in ESPRES.eu, and there's also a tutorial, and there's also one paper that is going to be published in environmental modeling and software if you are more interested in the topic. Okay, that's all. Thank you very much.
Thank you very much, Angel, for your presentation. And I invite everybody who is interested in Angel's work to reach out to him after this session. Perfect. So I will ask Angel to leave the stage. Okay, perfect. And now I would like to welcome our third speaker of today, that is Josue Aduna. He is a behavioral and data scientist at Life Mobility. I kindly ask. Hey, good morning. How are you?
Hi, Andrea. Very good. Very good. Do you hear me?
Yes, we do. It's a pleasure to have you here. So Josue is going to talk about mobility scan and I leave the floor to you, and we are all happy to enjoy your presentation. Thanks, and do not forget to switch off your camera after you have shared.
Excellent. Thank you very much, Andrea. And hi, everyone. Thanks for being here. My name is Josue, and I will present a Shiny app that was developed to foster sustainable mobility under an initiative called Live Mobility. So what are the benefits of sustainable mobility? Live Mobility is a complete Android, iOS, and web application that helps companies to save money, reduce pollution, improve public health, and save commuting time. So sustainable mobility can also be fun, and Live Mobility rewards it. For more information, please visit livemobility.com. So this app generates a mobility scan from a set of postal codes for a company. For this demo, I chose to sample 500 random addresses in London for no particular reason other than being an open engine online. Here, analytical data is generated for every employee, but I'll skip this step to save some time. The analytical data contains distance and duration information for every different means of transport down here, like car, public transport, and bike. We have some summary statistics. For example, we can see that on average, there's a distance to work of 11 kilometers and 32 minutes on average. So, and in this section, we calculate some key benefits of adopting sustainable mobility. For example, we have 72% less costs, 76% less carbon emissions, a total increase of burned calories, since the baseline scenario is only considering car trips, and a slight compromise of commuting time, since we're considering then bike as a transport type. So the way in which this is done is through a set of customizable options. Here we have some representative allowances that companies incur depending on the transport type of their employees. For example, lease car, private car, public transport, and bike. This all can be customizable and it's live. The baseline scenario in this case considers only car trips. So we see all red here, 500 car trips, but it can be customized right here. I leave it as before. And this is compared with an advised scenario that considers reasonable thresholds for the usage of bike, e-bike, and public transport. So, for example, we have that employees less than 7.5 kilometers from work are advised to go by bike, less than 15 kilometers by e-bike, right here, and a duration threshold for public transport. So as we can see, this generates a very different mobility profile for the company. Finally, this section generates a heat map of the routes on the map. In the case of the baseline scenario, which is only cars, we can see all red, looks quite congested. But if we consider a more sustainable mobility dynamic, which we can change right here, things look different. Remember the colors? So green was for bike, yellow for e-bike, and blue for public transport. So just to wrap it up, this is an overview how the city can be unblocked, as well as reducing pollution, saving some money, possibly some time, and it's a healthier behavior. Well, that's all for now. Thanks for watching. I invite you to the Q&A session if you're interested to learn more about live mobility or if you have any comment. See you there.
Thank you very much, Josue. That was a really interesting talk. So I really stress again, whoever may have some questions for Josue, please join him in his private Q&A session that will take place straight after this session. Thank you.
Excellent. It's been my pleasure.
Thank you
Andrea.
very much. See you soon. Okay, so now we welcome our fourth speaker. Our fourth speaker is Lorenzo Busetto. He is a researcher at the Institute of Remote Sensing of Environment, National Research Council of Italy. And I would like to invite him on stage. Good afternoon, Lorenzo. It's a pleasure to have you here.
Good afternoon. Thank you.
So, Lorenzo, we talk about developing Shiny applications to facilitate precision agriculture workflows. I will leave you the stage, and I'll remind you to kindly switch off your camera once your your screen is sharing. Thank you very much.
Okay. Hello, everyone. In this short demo,
Lorenzo, I think you're sharing just your. Yeah, I think you may have switched off the screen instead of the camera.
Sorry for the mistake.
Do not worry. Do not worry.
I just pressed.
We are not that used to being online conferences, but we'll get better by the end of the conference. That's perfect. Thank you.
Okay. Is it okay now? Okay.
Yes, it is. Thank you.
Okay. So, as I was mentioning, in this demo, I will try to describe very quickly a Shiny application dedicated to allowing agronomists to record and query information about agricultural practices such as crop type, crop yield, fertilization, or phytosanitary treatments. And we are developing this app for the needs of agronomists of the Industrie Bonifiche Ferrari Servizi companies in Italy. So forgive me if the interface is in Italian. I didn't manage to translate it, but I think it will be comprehensible. So the app is based on a customized dashboard interface. We have several panels that allow to store and query different kinds of information. If a user wants to start inserting information about his fields, he has first of all to select an area and a year, and then import the boundaries of its fields. So in this way, we get a map, and we can just click on each field and select from a dictionary the crop type and variety which is associated to each field. So in this way, we manage to create a crop time map, which is fundamental information. Rather, we can insert all of these manually, or we can import from a shapefile or from a table, like I am showing you here, from an Excel table. And we manage to easily fill in all the information, and then we can save it with these buttons on a standardized format. So we can insert data in this way, but we then have another panel in order to query the data. So we can automatically load all the data sets available about crop type. And then here with this selector, we can select which year we are showing, or we can just highlight which fields were cultivated with any crop type using these selectors on the right, or we can even just click on a field and see in the associated table what was the succession of the different crop types in the different years. All of these queries can be exported to HTML reports, to Excel files, to shape files, etc. So this was regarding crop type. We can also insert information about crop yield. We have a very similar interface in this case. So again, I can just select one field and insert the average crop yield. But you can see that I can also manage to see specialized information. This can be done by importing a raster file generated using an approach similar to what my colleague Luigi will show you later. And if I import this raster, I can manage to have a specialized information about the yield, which is important for agronomists. Finally, the last kind of information that we can insert is regarding agricultural practices. So, in this case, the interface is similar but more complex because we can have more than one practice to insert for a given field. So, for example, for this field that doesn't have any information associated, I can, first of all, click here to start inserting the new data. I can insert, in this case, information about sowing. So the amount of seeds that were used per hectare and the date of the sowing. And then I can start and insert additional information, such as, in this case, a fertilization. So I can select a specific product from a dictionary. I have the information about the characteristics of those products, unit of measures, again, the amount that I spread, and again, the date of my treatment. And I can save, I have all these datasets on the table here below. Finally, I will try to wrap up any useful feature, again, is that I am able to query the datasets, automatically loading whatever I have. And in this case, the query is more complex because I can either show everything, or I can show only the sowing treatments or only the fertilizations. And in this case, for fertilization, for example, I can show only the last treatment, showing which product was used, or the amount of nitrogen or phosphorus that was applied, etc., but also the cumulated values. So I can sum and can easily find out how much nitrogen or how much phosphorus was applied to a given field between a starting and ending date. And again, this is an important information for agronomists to see the balance of nutrients. And I can export all this data again to shapefiles, table, etc. So that's it. I hope I wasn't too long, and I hope it was interesting, and to see you in the Q&A.
Thank you very much, Lorenzo. That was interesting indeed. There is a lot of information I can extract from your application, and I'm sure more of the attendees will have questions for you in the Q&A session. Thank you very much.
Thank you very much for organizing.
It was a pleasure to have you here. So I would like to welcome on stage our last speaker for the session today, and is Luigi Ranghetti. Luigi is a researcher at the Institute for Remote Sensing of Environment, Consiglio Nazionale delle Ricerche, and he is going to talk about GUInterp, a Shiny GUI to support spatial interpolation. And I would like to have Luigi on stage. Luigi, we do not see you on stage yet. Okay, okay. Here you are. Hey, welcome. Good afternoon. It's a pleasure to have you here.
Hello to everybody. So I'm sharing the screen.
Perfect. Thank you very much. You have 5 minutes to briefly introduce your Shiny app, and then you'll have more time in the Q&A session to further develop, to further showcase all the features that your app have. Perfect. We see your screen.
Okay. Hello to everybody. And this presentation is about GUInterp, which is a Shiny GUI written with the aim to provide an easy-to-use graphical instrument to perform a spatial interpolation. It was originally written as a module of the application shown right now by my colleague Lorenzo to generate yield maps. Then, thanks to the availability of our client Bonifiche Ferraresi, that module was generalized and released as an R package with free GNU license, so everyone can exploit and use it. The online reference at the address I've copied in the chat, the first address, includes instructions for installation and launching command. Simply, the command can be launched with this command, GUInterp. This demo on the top of the screen is a Shiny Apps host which can be launched to explore the GUI before installing it. This is the interface. First of all, we need to load the points to be interpolated, and an optional polygon vector file which can be used to delimit the area to be interpolated. You can use the bounding box of points or load points or load polygons. Then we load points to be interpolated, and we have to choose which variable contains values to be interpolated. After this, the interface is shown. In the middle part, we can see the distribution of points, both in a histogram and on the map. So we can see all the points or select single polygons, in this case, single fields, or reduce the number of points to be visualized. This can be useful in case we have a large data set, because the visualization is interactive. So reducing the number of points will reduce the time required to update the map and the histogram. On the right part, we can see 4 boxes on which we can set the interpolation parameters. I will not show all of them. We can see all of them in the Q&A session. In the first box, we have some filters. We can filter points to filter outliers, basically. Basing on the point distribution, you can see that enabling boxes or changing the filter values, the histogram and the map are interactively updated. We can filter also using the borders. For instance, we can filter points close to the polygon borders, or we can draw exclusion polygons in this way. Okay, now. Another possibility is to define the semi-variogram in case we are using an ordinary kriging. With this interface, we can try to optimize automatically the semi-variogram, or we can change manually the values of the semi-variogram parameters. For instance, I can change, okay, in this way. When we are ready, we can launch the interpolation. So it starts. The interpolation is performed using a gstat R package. And when it is finished, the output raster is shown on the map. At this point, we can change, refine the parameters, or if you are okay, close the interface. So this is the current beta version. Further development is planned. For example, I plan to add the possibility to load the raster covariates, so to perform universal kriging. And if you have a suggestion for development, we can speak about in the incoming Q&A, or you can suggest them open a GitHub issue. In the Q&A, if you want, I can show an interpolation on a real case dataset and to see additional details and other settings. Thank you.
Thank you very much, Luigi. That was right about on time. I also saw that you shared in the chat session the links for your app. That was really great. Thank you very much.
Bye.
So I would like to thank again the speakers of this session, Agostino, Josue, Lorenzo, and Luigi. And I'm sure they look forward to answering your questions in the Q&A session. So I really invite you all to join them. And I would like to steal another minute to thank again the organizers and all the committee for this terrific work they have been doing for having us participating in this virtual session. It was a pleasure, and let's talk and let's see each other virtually soon. Thank you and bye-bye.